Alrighty, so we just learned about relations, right? Just a set of any ordered pairs. Okay, now we're going to learn about specific type of relations that we're actually going to use. They're incredibly useful in mathematics and in engineering, and actually almost all machines are created and programmed using functions. So what we're going to do, the goal for today, is to determine whether a relation is a function. Okay, so we're going to figure out when those relations, those groups of or sets of ordered pairs classify also as a function. Right? So a function is a relation, obviously, in which there's exactly one output for each input. Right? Exactly one output for each input. Okay, so what that means is an input is the x's or the domain, right? The D stands for domain here. They have to have one arrow and a mapping coming from them. If there's two different arrows coming out of one input, right? So if the 5 was going to the 3 and to the 4, okay, then that would no longer classify as a function. Okay, for the range or the outputs, okay, the y's over here, right? They can have as many different arrows pointing to them. It doesn't matter at all. So these can double up. It doesn't matter that 1 and 2 are both going to 3. It doesn't matter that 0, 4, and 5 are all going to 4. Right? That doesn't bother it. This is still a function. So this is an example of a function. That mapping right there, which we could obviously represent as ordered pairs, or a graph, or a table, just like we learned in 1.6. Okay? So there's a couple different types of functions. We're going to start classifying them a couple ways. First one's a discrete function. So a discrete function is one like this, that the points are not connected. So you got boop, 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 and all those spaces in between, right, that you don't connect the dots. Right? Basically, if there's gaps between your points, then it's a discrete function. A continuous function is just the opposite. Right? So you have all these points, right, but also all the spaces in between are also part of the function. So all the points are connected on a continuous function, not discrete. Now, the easiest test, okay, for a graph to see whether or not something is a function. So remember, we tested over here with a mapping, right? You got to look at the domain and see if there are any doubles. If there are any double arrows coming out of the domain, then it's not a function. Well, similarly, you can test on a graph, right? And the test for the graph is called the vertical line test. So the vertical line test is if you draw vertical lines, you can draw an infinite amount of vertical lines all over the graphs. If you ever going to hit your graph more than one time, okay, so twice or 3 times, then it's not a function. If you either hit 0 times, like over here, or 1 time, like right here, right, you're only intersecting that graph 1 time, just at that point, then it is a function, right? So this first one, if you draw that vertical line right there, you're going to hit the function twice, right? And since you hit that function twice, this is not a function. Same for this one. This line's good, that line's good, but once you get here, you hit it twice, so not a function, right? This third one, good, 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 all over the place. So it is a function. This one's good. And the last one, you're good in all these spaces. Now, the only ones that are close are this one right here and this one right here. But if you see, there are open circles right there on that middle one. So although there's a closed circle up on top and on bottom, right, that open circle means it's only hitting it once. So this one is also a function. Now, function notation is the same as an equation, you're just writing it differently. So where we've always been writing equations as y equals like 3x minus 8, right? Instead of writing y, we're going to write f of x. Okay, so it's just a different notation. So just know that y is the same as f of x, or f of x is the same as y. Okay, what's going to change here is if, for example, I wanted to plug in, 2 for x, the way I would write this is f of 2 equals, and then anywhere I see an x in your equation, you're going to write 2 instead of x, just like you did for the f of x. Okay, and you could work that out and you get negative 2. Okay, so f of 2 is the same as like y equals negative 2, right? Now, a couple examples. We're going to determine whether a relation is a function. Okay, so we're going to look at this mapping first. This mapping, remember, we just need to test the domain and see if there are any double arrows coming out of it. Well, there are 2 arrows coming out of the 1, so 1 is no, not a function. That's a p. Okay, And B, all right, we haven't done it with a table yet, so let's try it now. What we need to do is we need to, again, look at the domain and see if any number shows up twice. Okay, so it's -9, -2, 4, and 11. None of them show up twice, so we are all good. Yes, this is a function. Now, number 2, we're going to talk about these lunch periods. Okay, so there's 3 lunch periods at school. First period, 352 students eat. Second, 304 students. Third, 391 students. We're going to make a table showing the number of students that eat each period. Okay, so let's say the period. I'm going to draw my table this way just so you can see it both ways. And number of students. Good. So during period 1, there are 352. During period 2, 304. Period 3, 391. Now we just need to remember that the period is the domain, or x's, and the number of students is the range, or the y's. Okay, so to determine the domain and the range, I know that the domain is the set. Remember, we use that squiggly parentheses for set of 1, 2, and 3. And the range is 352, 304, 391. Now we're going to write it as an ordered pairs, as a set of ordered pairs. So these ordered pairs are 1, 352, those match up, 2, 304, and 3, 391. Now to graph this little guy, we don't actually need this part and this part, right? Because they're all positive. So we could just make it real big so we can see it better. Now we've got 1, period 2, period 3. Now, getting all the way up to 300, we don't have to actually write all those. What you could do is you could just draw this break. If you draw that break in there, right, that symbolizes that you're skipping a whole bunch of numbers. So let's just start right at 300, and we'll do 350 and 400. Okay, that way we don't have to draw all those little lines. So I need 1 at 352, 2 is at 304, and 3 is at 391. Now the dangerous part about this is it doesn't look to scaled, right? These would normally be way, way up higher. Okay, there'd be a big gap in there. And the last part here is this discrete or continuous. Remember, discrete is when the points aren't connected, and continuous, they are connected. Well, these are not connected, so the answer would be discrete. We're going to determine whether x equals -2 represents a function. Okay, so if x is always -2, that means it doesn't matter what y is. So let's draw it as a mapping. X, or domain, right, is always -2. Now the y's could be, or the range, could be anything. So we have all of these, right, and so on and so forth. Well, -2 would be going to all of them. Okay, so remember that you can't have more than one arrow coming out of your domain. So the answer to this one would be not a function. You could also represent it as a table or a graph. Lots of different ways to do that problem. Now for little function notation practice, we've got f of x equals 3x minus 4. We're going to find f of 4 now. So anywhere we see x's, we're going to plug in 4 and solve it. 3 times 4 is 12. 12 minus 4 is 8. So f of 4 equals 8. And f of 8, 3 times 8 minus 4 is 24. Oops. 24 minus 4 is 20. So f of 8 equals 20, and f of 4 equals 8. We're also going to practice with these squareds right here. Make it a little more complicated. We're going to plug in 3 for all of the t's. 1248 minus 160 times 3 plus 16 times 3 squared. Now we have to remember our work with order of operations. Okay, so for the order of operations, we have to do our squared first. So 3 squared is 9. 1248 minus 160 times 3 plus 16 times 9. Now we can do all our multiplication, so 160 times 3 is 480 plus 16 times 9, we can do that part. There's 144, and then we can do adding and subtracting. So 144, 1248 minus 480, and we get 912 as our answer. Perfect. Now this last problem is a little bit tougher because we're going to plug in 2z for all the t's. So let's rewrite it first with all the 2z's in there. Okay, now we need to square our 2z first, but the square is acting on both the 2 and the z. Okay, so what that means is we've got 2 times z, or 2 times 2, which is 4, and z times z, which is z squared. Okay, so 2z quantity squared is actually 2 or 4z squared. Okay, now we can do our multiplication just like we did above. 1248 minus, 16 times 2z is 320z plus 16 times 4z squared is 64. 16 times 4 is 64. Z squared. Right, and that's as far as we can go, so we could just leave it right there because there are no like terms. And that's it.